On this 6B, it deals with what we call measures of variation. All right, so we're going to talk about, first of all, this is going to be on your project, but this is called a 5-number summary. So y'all, when we look at the 5-number summary, we're looking at the low value of the data, the lower quartile, the median, the upper quartile, and the high value. So I'll sort of go through these and tell you what they are, and then how to make what we call a box plot that can show these 5 things, okay? Alrighty, so before I get into this, we're going to look at what we call the range. So y'all, the range of a data set is the difference between the highest and lowest values. Okay, so to find the range, you're taking that largest number, subtracting that smallest number, and that'll give you your range or how wide that data is, okay? All right, so range equals your high value minus your low value. So this is basically 2 of the numbers from the 5-number summary, your low value and your high value, okay? Those 2 will give you your range. Now we got words like lower quartile, upper quartile. So let me go through those. These are your quartiles. All right, so we got a lower quartile first. Really, when I think of quartiles, I'm thinking of stuff that they're splitting into fourths. Okay, so you're thinking about fourths on this, okay? They're splitting the data up into 4 sections, basically. So this lower quartile, or we often call it the first quartile, it divides the lower fourth of data from the upper 3/4 of data. And to find that, you find the median of the lower half of data. And y'all remember, median is the middle number, right? You're finding what's the middle value. So you do that with the bottom half of the data, that splits that into the lower quartile. Then we got a median quartile. And basically, this median quartile is the median. It's the median of the entire data set. All right, then we got our upper quartile. We often call that the third quartile. And actually, this median quartile is often called the second. I forgot to give y'all that one. So the first quartile is your lower quartile. Second quartile is that median quartile. Third quartile is the upper quartile. And let me let one in real quick. And the upper quartile divides the lower 3/3. Whoops, I meant 3/4. So it divides the lower 3/4 of data from the upper fourth of data. So it is basically the median of the upper half of the data. Okay. Now, I'm going to show you how to make a box plot. And they often call this a box and whiskers. Okay, because the box plot is a visual way to represent these 5 number summaries, okay? So it is a visual way to represent the 5 number summary. All right, y'all. So what we got, we're going to have a box. And then it's got what we call whiskers that come off of it. So this left whisker is the low value of your data. This right line over here, the right whisker, that whisker is the high value of the data. So then inside the box, we'll have a line inside the box. This is the median of all the data. So this is your median of all data. So basically, it's your second quartile right here. So your second quartile, if you notice, is dividing all this data in half, okay? So how about this line right here? It represents the lower quartile. And remember, it's the median of the lower half of your data. Okay, so once I know the median of the overall data, I take my lower half of data and find that median to get my lower quartile. And then y'all, this side right here is my upper quartile. And remember, the upper quartile is just a median of the upper half. Okay, so this would be the first quartile, which is my lower, second quartile, which is my median, third quartile, which is my upper quartile. The left whisker is the low value, right whisker is the high value. So that's dealing with your five-finger summary and how to do your box plot, okay? You're just finding a lot of medians on this. Now next, I'm gonna go back over standard deviation and give us that formula. So your standard deviation equaled the square root of the sum of the deviations from the mean squared. So you find all these deviations, then you're squaring them all. Once you got them all squared, you're going to add them together. That's what that is. And then that is divided by the total data values minus 1. So y'all, I'm actually going to do the steps for this, okay? So the steps for finding the standard deviation. The first thing you got to do, compute the mean of the data. And y'all remember, to compute the mean of the data, that's the average, you're going to add all them datas together and divide by how many you had. Now, once we compute the mean of the data, then we're going to find the deviation from the mean of each data value. So how far from my average was each of these points, okay? That's the deviations. So we find all these deviations from the mean for each data point. Then we find the squares of all deviations. So to square something, you're basically multiplying it times itself, right? All right, once I squared all these deviations, I'm going to add these deviation squares all together. So find the sum of the squared deviations. All right, so we've added all these squared deviations up. We're then going to divide that by the total data points minus 1. So that's doing this. We added them together. We're now going to divide by the data values minus 1. Once we got that answer, then we take the square root. So the square root is our last step. So we take the square root and have our standard deviation. Okay, so shorthand for standard deviation, okay? So that's our last step when we take that square root. So y'all, let me just play with y'all on an example on this one. I'm going to find the standard deviation of the data. Now my data is 11, 12, 12, 11, 20, 17, 10, 17, and 6. So let's see how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 data values. Okay. So now remember, first thing we want is our mean. So the mean, I'm going to add all these together and divide by 9. So you would have 11 plus 12 plus 12 plus 11 plus 20 plus 17 plus 10 plus 17 plus 6, all divided by 9. All right, y'all. Hey, one of y'all got a calculator? Add that up and divide that and see what we're getting on that. And I'll pull my chat up. So I'll probably just add all them together, get that answer, and then divide that by 9 on that. Now I know y'all should be between what's the low number? 10 and the high number is 20. So your answer should be in between 10 and 20 somewhere on that. So 12.89. So Morgan, I'm probably going to make that a 12.9. I'm just going to round mine 1 decimal place. But y'all, that is perfect. Okay. Now I'm going to make a column for all these data values. So I'm going to make my column over here for my x's, which are my data values. Then I'll take my x's minus my mean. So this will be our deviations. Then I'll do my x minus means squared. Okay, so my x's minus this mean of 12.9, and then my squared values. Then we'll sort of come over here and play with our formula, okay? So my x's were 11, 12, 12, 11, 20, 17, 10, 17, and 6. So there's my 9 points. Now what's nice is whatever I get for 12, I'm going to get for that 12, 11, and that 11. And then I got the 17s that repeat. So, all right, y'all. So what we want to do now, take 11 and subtract 12.9. So if you do that, you should get a negative 1.9. So I'm going to do all of these. 12 minus 12.9 is a negative 0.9. So that means this one will be a negative 0.9. I know what 11 is. That's a negative 1.9. So now these being negative, that tells me that these numbers are all smaller than that average. Now let's start with this 20. 20 minus 12.9 left me 7.1. 17 minus 12.9 left me 4.1. 10 minus 12.9 left me a negative 2.9. 17 I did, that was 4.1. And then 6 minus 12.9 left me a negative 6.9. So I took all these data points and subtracted the mean, which was 12.9, and got these values. Now I'm going to take these values and multiply times themselves. So we're going to square them and get this column of numbers. Now, if you do these on a calculator, you want to put negative numbers in parentheses. So y'all, I'll show you how I'm talking about. So when I do a negative number, you got to do parentheses, negative 1.9. Close the parentheses, and then on the left side, hit that x squared button. That'll put the exponent up there to square it, and then we hit enter and get 3.61. So remember, when you square any number times itself will give you a positive answer because like signs are always positive. All right, then I would do negative 0.9. So parentheses, negative 0.9, close parentheses, and square that. I get a 0.81. So that's going to give me another 0.81. Okay, so then when I did negative 1.9, we know that gave me 3.61. 7.1 times 7.1 is 50.41. 4.1 times 4.1 is 16.81. Negative 2.9 times negative 2.9 is 8.41. 4.1, I know that is 16.81. And then finally, negative 6.9 times negative 6.9 is 47.61. So here, I just now found all the squares of the deviations. So my next step, find the sum of those squared deviations. So they want me to come in here and add all these up and get a sum from them. So y'all, when I added all these up, I ended up getting a 148.89. That is now the sum of all these deviations. All right, so now I'm just going to put all this in the formula because I'm to the point where I can do my formula. So a standard deviation will equal the square root, and this is all my square deviations, and that's the sum of them. So 148.89 goes on top. And remember, we're dividing all this by the total data values minus 1. Well, y'all, we said we had 9 data values a while ago. So that's going to be 9 minus 1. So notice my first move. Divide the total data values minus 1. So we're going to divide this part. So 148.89 divided by 8 basically gives you 18.61125. So I'm just going out a lot of digits so that I can be more accurate. The more digits you have after the decimal, the more accurate your answer will be. Hey, also, then I took the square root of that number. So if you take the square root of 18.61125, you'll end up with a standard deviation of 4.3. So that means on average, all my data points were about 4.3 units from that 12.9, okay? Now, y'all, so questions on that? So that was your standard deviation stuff. And like I said on the front page, was basically about your 5-number summary. So that's what they're talking about right here, your low, everything that's on this box and whiskers. Low value, first quartile, second quartile, third quartile, and your high value. So what I'm going to do Monday, I'm going to sort of bring a example to show y'all how to do the project. So what you want to think of before Monday is what kind of question do you want to ask people? And then think about a way that you might can ask about hopefully you can get 20 to 25 people. But I would definitely want at least 10 or more, okay? So I could do a Facebook poll or anything. Like I said the other day, how much do you pay for your cell phone? How many gallons of gas do you buy a week? Um, how much do you spend on groceries? Any kind of questions that you can take data from, okay? Because with that data, we're going to find this kind of stuff. Well, before this, we'll find our mean, median, and mode. So it's got the mean, median, and mode on it. We'll do our 5-number summary with their low value, all these quartiles in the high, and then we'll find our standard deviation. I'm also going to show you how to make a chart. Because on the project, they want y'all to make a chart based on your data and the frequency of the numbers. So we're going to make a frequency table to show what numbers occurred more than the others, okay? And y'all remember that frequency table? We did that one day with the cumulative frequency and all that fun stuff. So I'm gonna show you how to make charts using that in Excel. Okay. All right, y'all. So let me see. Do y'all have any questions? All right, so I don't really have a bunch today. I just wanted to show y'all the 5-number summary, the box plot, and then that standard deviation again. Monday, like I said, I'll put a handout in MathLab for you, not MathLab, but in Blackboard that sort of goes over the instructions of the project. And then I'll give you an example of a prior student's stat project, okay? So that y'all can sort of look at that also.